So hi everybody, welcome to my talk here about the magic of baking service provisioning and consumption with Crossplane and ServiceBindings. So actually my name is Timo Salm. I'm a principal solution engineer, so pre-sales at the VMware Tensor division at Broadcom now. So we were acquired by Broadcom VMware, and therefore I'm also now part of Broadcom. In my role, I'm really focusing on, at the end, solving the problems on the customer side, in best case with our products, but also a lot with open source solutions. So on the modern infrastructure side, platform, high-level platforms like platform as a service, and also like things like for the developers with the Spring framework, etc., because it's also something we provide. Today, our talk will be really about platforms and services and how to consume them. Because at the end, it's like cloud-native applications, they provide a lot of value for the business. And in the end, it's also providing a lot of challenges, especially for developers, because of the cognitive load. Compared like in the past, not only the applications and the architectures that are a lot more complex, also like from an infrastructure perspective. So modern infrastructure provides a lot of flexibility, but there are a lot of more moving parts. The abstraction in a lot of cases is really on a different level compared to in the past, where the developers just packaged the software together, handed it over to operations, and they were responsible for everything. So the question is, how can we actually reduce the cognitive load, and especially also like in the modern world, have a clear separation of on concerns, because it's also usually a lack at the companies. So who's responsible for managing the applications on Kubernetes? Who's responsible of providing the clusters, etc.? That's usually clear, but there's a lot of like uncertainty who's responsible for what. Therefore, also Kelsey, like I would say the VIP of Kubernetes, wrote 2 years ago, so in the future we will have really this platform experience. So the developers, like in the past, where the operations were responsible for handling all the stack where the application runs, so the VMs, etc., middleware, back to the past at the end. The developers, they only write their code, minimal configuration, self-service, they provide it to the platform, and the platform is completely automated in doing the rest. That was 2 years ago, I would say directly after he left Google. Not sure whether that's, what the reason was for him. Maybe he had this vision all the time, but it didn't happen. But yeah, and it's like 2 years later, I'm not sure whether too much changed. So it's still like with every customer conversation I've had, there are only a few customers that like, yeah, so from our side, everybody's happy, everything is working. So therefore, let's talk about one important aspect about like this platform journey and the user experience, and that's really self-service for data services. Because especially with modern applications, so if you have a microservice application, doesn't have to be a microservice, but you need a lot more data services than in the past. So not just like one database. There's a lot more actually that's required. So caching solutions, asynchronous messaging, etc. So a lot more need also to do this service provisioning for the developers. And fortunately, we have solutions for that. So there are technical solutions to actually implement that. For sure, there's still a lot of effort to implement it in a way that the users are happy, and also from operations side, it's not too much effort. One of the solutions is Crossplane. So who has already heard of Crossplane? Okay, the majority, I would say. How many are actually using it? Okay, few. How many of you actually built a composition or something like that, or composite resource already? Okay, so at least some people will learn something today. That's good. This is what we're really focusing on, is this Crossplane project today, because what it provides, so the first focus of it is bringing like non-Kubernetes resources into Kubernetes. Because there are also a lot of tools available to actually manage resources in Kubernetes, and ideas or concepts like GitOps, etc. And if you run your application on Kubernetes, it would be also great to manage all the other resources, like, for example, data services running in the cloud, or Helm charts that you have via Kubernetes. Resources at the end. That's one focus of it. So bringing those other resources from the cloud, etc., into your Kubernetes management. The second one, which is I would say even more interesting for us now is like it's able to provide you to give you a way to provide higher abstractions of those services, etc., that you want to offer via Crossplane. So we will have a look at both today. Crossplane is completely open source. There's for sure vendors behind it, so Upbound is providing commercial offering on top of it. But yeah, this is mainly focused or 100% focused just on open source and those capabilities. Let's have a look at all the building blocks, because that's really how Crossplane works. There are a lot of different concepts and building blocks that provide you those abstractions and also like access to those so-called managed resources. And usually those managed resources, so I would say Kubernetes primitives that are related to external resources, they are usually provided by so-called providers. And there are providers for several, like public clouds, providers for Helm charts, which we'll use today, providers for Terraform, so also you can just run Terraform and more or less have the state within Kubernetes. So more or less for everything, there are providers that provide those managed resources. So let's have a look how actually our example is set up for that. So let's check. I have a Kubernetes cluster. I installed the Helm provider because that's the easiest to start with. We have all the data services available as Helm charts. And we can directly use actually the managed resource here, which is a release. That's something we can easily check via kubectl plugins here. So what are all the resources that will be applied by this provider? And we can see we have this custom resource definition of a release. I said that's special to this specific provider. If we have a look how that looks like, so it's just a CRD. So I would like to actually install this Helm release of the Bitnami chart, PostgreSQL in this version. I define basic parameters like how much storage I'd like to have for this database, configure or set the configuration for the provider, usually in AWS, etc. For those providers, there would be like credentials, etc. But here it's also very basic, and that's it. So I just like apply it, and after it's applied, I can easily see that the release is there, and then based on what the Helm chart is actually doing, I can see I have a pod running with my database, secret with a credential, which is in this case just a password. Great, so now I have my database provisioned. As that is just an example. So what's next? At the end, like we're talking about user experience, we're talking about abstractions. So if I'd like to have an application and consuming the database, I think I need more than a password. So the question is, I didn't configure anything, as you saw. How do I get access to this like username, database name, port, etc.? And that's something I can also easily do with Crossplane. So if we have a look at here, at this Helm release, we have the ability to define connection details. And just one more time, so this release here, you can see it's Crossplane. So it's a managed resource by Crossplane, which means you have in all those managed resources from Crossplane, also from community, you have usually those configurations that you see here. So I have the connection details, and there for every a resource that's actually provisioned by this Helm chart, I can actually get information. So you can see I'd like to have the host, and the host, for that I just use the service that will be provisioned by the Helm chart, and there the spec cluster IP. Same with the port. So I'm just getting them from the resources that are applied to my cluster. For sure, it's important to first check what will be applied to see like what are the naming conventions, etc. But then it's like with that I'm able to get all the details into one secret. Like here, for example, also the username, which is specified in this case for this Helm chart in like the environment variable, but I'm able to get it via this way. The last thing I do is I define where the secret with all the different keys will be created. So in my namespace with the name Postgres connection secret. And That's something I can check, sorry. For sure. We'll just take a second. In the meantime, I'm going to also show you like how developers would then attach it. So this is like how the application looks like as a standard deployment I have here. In this case, it's an application. It has a in-memory database, and only if I have the configuration available, so it's based on Spring Boot, it will actually connect to the database. This is how then it looks like, because I have this contract. The name of the secret was defined here. So that's like the Postgre connection secret. And the deployment is just referencing that, like here, secret key ref, so like just Kubernetes way of referencing specific keys in the secret. If we go back and have a look at our deployments, we can see they are running. Despite the inclusion one, for whatever reason, I think it just takes a few seconds. But we can see we have this one secret. And within the secret, here we have 5 keys. We can also have a look at it. So via a few secret plugin, you can see database, host, password, everything we actually need. You also saw that in the deployment, it's attached. And with that, I have everything I need. So I have a defined like secret. I have a structure. That's something I could document for this type of data service I want to provide. And the developers, they can just put it into the deployment. Great. So the question is, what's next? We have like a defined structure for secret. We have a way to actually provision specific managed resources or databases from specific providers. But then it's like we don't really have an abstraction on top of it. Because if you compare it, so what we have to configure here for this Helm chart, it's a lot. And that's not something I would actually ask developers to do. It's just too complex for them, to be honest. So you need some expertise to do that, and this is just like a Helm chart. If you are like managing AWS services via Crossplane, it's a completely different story. So yeah, what does actually Crossplane provide for that, and how can I use it? And there are a lot of, or several really important concepts or building blocks for that. And the first one, which is the most important one, is a so-called composite resource, which actually provides or defines this higher level abstraction that you're using. So you create it or you define it based on, okay, what are the requirements from the developer side, what they want to specify. So in our easy example, it's more or less just like, okay, so they need the amount of gigabyte, for example, for this PostgreSQL database, because that's what they know is like, how much data do I want to store there? You define it, so it's really very similar to Kubernetes via so-called composite resource definition. This is where you define like what is the interface for the developers. The composite resource is then the resource that is actually creating it. And then you have like a composition which is defining how the managed resources are configured. So this is like the implementation of that. And additionally, and that's something you will see later, so we are talking about Crossplane version 1 or 1.20 here. There's already a pre-release of Crossplane version 2 where there will not be a claim anymore. But in this case, there's still this claim, which is the real interface for the developers. The reason for having like this claim, and you will see it in a second, that looks exactly the same later than the composite resource, is the fact that a composite resource, a composition, and also a composite resource definition, so all of them that are there in the line, they are not namespaced, scoped. So they are cluster scoped. But usually developers, they get a namespace and or only access to a namespace. And therefore, there's this claim to really have this namespace resource. As said, with Crossplane 2, this limitation will be mitigated by the fact that also now composite resources are namespace scoped. So let's have a look at it, how it looks like. Let's start with this composite resource definition, or XRD. At the end, it looks like a custom resource definition. We have a kind here, we have a plural. The X you're seeing in front, that's actually just naming convention because of the fact that we will have a claim without that X. With the Crossplane 2, you can remove that X because we don't have a claim anymore. Then we have the definition of the interface or the schema. In this case, as said, we only want to have this storage property with the amount of gigabyte. You can have multiple versions, or actually you can add additional versions later if you want to add more properties, etc. The thing is, it's not possible to change existing properties also in new versions. So that's something not supported. For that, the recommendation is just create a new composite resource definition. You can also see what I additionally define is so-called connection secret keys. With that, I control which actually secrets are accessible by those composite resources. And last but not least, I also define the name for the claim name. And there you can see, so that's the interface for the developers. They will have a custom resource called PostgreSQL database, which they can create and then also interact with. The next thing is this composition. So as I said, it's more or less the implementation of this interface. You can see I'm referencing it here also via the version. So yeah, for every version, you can have a different composition. And in this case, as you know, it's just like this Helm release I'd like to apply. This here, and you can see it, is the pipeline mode. So for those people that are aware of Crossplane, I think in the past it was more usual to use the resource mode, which was directly defining the resource and then doing some filtering and templating. But that's deprecated with Crossplane 1.20. So the pipeline mode is the preferred one. And you can see, so we have this resource, but you can also see placeholders here. So those are all placeholders for templating that will be replaced by some information, for example, from the composite resource. And that's possible via so-called functions. So there are functions that come out of the box with Crossplane. You can build your own, and they are actually doing the templating for you. So you can see for the function we are referencing here, it's just patch and transform. And if we scroll down, we can see that here are all the patches. For example, I have in my composite resource as only real value the storage or configuration. And then you can see I first converted from, in this case, it's a float, so just one gigabyte, into a string, and then the format adding the gigabyte behind, because this is how the managed resource is, or the Helm chart is accepting those configuration values. A lot more like using the name of this composite resource, putting it into the release, and stuff like that. So it's this can be very complex at the end, but it's something provided by the operators once in best case, and then developers, etc., they don't have to care about that. Last but not least, we have our, at the end, claim in this case. So that's not a composite resource, but the composite resource looks very similar. We just have this kind PostgreSQL database, a namespace, storage, and what we also define here is what's the name of the secret we'd like to have. So more like, I'm a developer, I want to have this PostgreSQL database with 1 gigabyte. Please write the secret into a secret with the name Postgres connection secret. So with that, it's getting very basic. You can see I have applied this function. That's one just available for you to consume. We have our claim, so the PostgreSQL database. And as I said, it's because it's really a custom resource definition in this case, you can work with it as with any other resource within Kubernetes. Automatically created for us is this composite resource, as you can see, which is holding all the details about what's the claim it was created with, etc. And then we have our applied release here, based on this claim or composite resource. And so great, we have these abstractions, developers can use it. So if we would do that with all the data services, I think it's very easy to consume them and only care about what's really important or the requirements developers had, like it was in the past where they handed over an operational menu with some basic configuration. The question is, what else can we improve here? And there's more. So it's always about okay, what are the problems the developers have? And it's the only thing you can find it out by asking them. And then whether there are solutions that already solve the problem or not. And so from our side, one of the things we learned, it's still even if it's I know the secret, I'm responsible for deploying my application, I can easily create those services. It's still a challenge, and also from a security perspective, if you want to really provide an abstraction, a challenge, how can I get those secrets with the credentials into my application? So you have to attach them or set them by environment variables, as we saw, but still you need some expertise to do that and have to know how that works, and also internally, from, for example, Spring application perspective, etc., what to set to get to your results. For that, we created two solutions. The first one is ServiceBindings specification for Kubernetes. There's also a reference implementation. The idea is that instead of adding those credentials via environment variables or mounting them, you just define this service binding with okay, here's my PostgreSQL database or the secret of it, and here's my deployment, and it will automatically attach this information. That's the service binding part, and then you still have to pick it up. So you need a specific contract, for example, with the secret, how the names are and the values or key and values. And for that, we have something else on the application side, which is called Spring Cloud Bindings. So the idea of that is that there's really a contract, and those libraries know about this contract, and then picking up the information that is mounted and putting it in the correct configuration properties. It's not only available for Spring, it's also available for, I would say, our common other languages. And in the end, it's this is why Paketo is mentioned here. If you're using cloud-native build packs, the Java build pack of Paketo is automatically attaching this library for you. So for the developers, they will just run their Spring application, have a service binding, and it will be aware of the backing service running in your environment. So short question, how many people of you are aware of cloud-native build packs? OK, not too many. Actually, I really recommend to have a closer look at. So it's also open source. We contributed it or built it together with Heroku, contributed it to the CNCF under the buildpacks.io project. At the end, what it does, instead of using for individual software development, so Spring, .NET, Python, whatever, instead of having a Docker file, doing Docker build, being responsible of base image and updates, etc., we abstracted away by so-called cloud-native build packs. So they actually recognize, based on the source code, whether it's Java, Spring, using Maven, or a completely different language that is supported, how to build a best practice container image without any Docker files. And then you push it to the registry, and it's just with best practice as the default image. What's special about it is you can rebase this image without having to rebuild the application. That's another aspect. And we also have one more component here, which is called, in the open source world, KPack, which we also contributed, which is running in Kubernetes, doing the builds for the developers, and also managing the complete stack. So let's say there's a new operating system version available. You just make the cluster aware of that, and then it will rebuild or rebase all container images that are managed with that. So at the end, it's the complete middleware operating system image patching is in the hand of the operators instead of the developers. So feel free to have a closer look there. So let's have a look how the experience is and how we can implement that and even improve the experience with the help of Crossplane. So let's get here. The first thing I have to do is actually define my service binding. And you can see what I do here is I have a custom resource, so it's also just something you apply to your cluster. And I have this binding. I want to have this service, which we actually chose the name for from our claim. And I want to attach it to this deployment. If you have a look at the deployment, you can see I removed everything regarding that, OK, I want to set environment variables, etc. And as already mentioned, also, this container image is already built with a build pack for Spring Boot. So this library that is like recognizing the specific format of the secret is already there. But there's something we have to adjust, because I have the secret, and you may remember I had a host in it, I had like password user in it. How should this library know that it's a PostgreSQL database, and I have to, in Spring, for example, set specific configurations for PostgreSQL? That's something we have to add to our composite resource here, or composition. You can see, in addition to those secrets I got from like the different resources that are applied by my Helm chart, I just add the value of type and PostgreSQL to the secret, and also, which is optional but recommended, the provider, so in this case Bitnami, as the biggest open source container catalog. With that, I now have a secret where actually this library knows, OK, it's PostgreSQL, so I know how the mapping is between my secret values and actually the configuration properties in Spring. Let's have a look. So the secret is here. Before it was 5. Now I have like 2 more configurations here. And I also have applied the service binding. You can see the service is bound, which means that actually it's attached to automatically via mutation webhook to my deployment. So here that's something that just was done by the service binding controller. Added the volume here with like the secret I have referenced in my service binding. And then I can also see that there is an environment variable set, so where it will be mounted to, so that the library recognizes where to look for those secrets. And actually, it's like, this is what it provides. There's one more thing we can do. And it's like, still, the developers have to define a secret name. How can we abstract that away? And that's something we can actually do via, sorry for jumping between the views here. Because in this service binding abstraction, there's one node that you can actually use provisioned services, like our claim that we have, with service binding and bind directly to it. And that works in a way that under status, there has to be like a binding information with the name of the secret. So what we can do with actually Crossplane is just add this to our composite resource. So we're just adding the status, their status binding, and there we want to like to have the secret. How can we do that? Actually, if we go back to our composition, we can see so what we did before from the composite resource, we copied over values to our release or managed resource. But it also works the other way around. So we are now copying from our managed resource, for example, information to our composite resource. So like the metadata UID, this is what we will use for the secret name so that there are no conflicts. And we will just set that as the spec, right, connection secret to ref. So this is the name of the secret and also the namespace. And also you can see that here, set status binding name to this metadata UID. And with that, we are in a way setting back the secret name, setting it in our composite resource. And the service binding specification then knows how to actually use those and attach the correct credentials. So let's have a look. We have our PostgreSQL database. We have our secret. And if we have a look at the YAML, we can see status binding. So that was actually set back to our composite resource, or then also our claim. So what we'd like to have. And at the end, the service binding is working attached to the secret that is just mentioned by this PostgreSQL database, which means we only need, like this PostgreSQL database, our service binding, the deployment, and with that, the developers don't have to care about any credentials anymore. Okay, so we're coming to an end. As already mentioned several times, so we used Crossplane version 1.20. There's already a preview available for version 2. And it's changing some, I would say, major things that are great from experience, because it's eliminating the claim because of the fact that the composite resources are now namespaced, so there's no need for claims anymore. Managed resources are also across support now namespaced, which is great. So this release, for example, that was applied was not namespaced, only like the resources managed by the Helm chart itself were namespaced. And also, like compositions are now supporting any Kubernetes resource. So before, you also had to use a provider for that. There's also a huge focus on backwards compatibility. But yeah, if you're like want to start your journey now, I recommend to trade out maybe with the current version and wait until like productionizing for the new version, because there's still like some things that will change and make it a little bit harder to actually migrate them to version 2. And yeah, that's it from my side. So if you'd like to have a look at the source code, it's available via this QR code. So also like the slides, in addition to, for example, the Google Drive with the slides. And yeah, I hope you learned something, enjoyed my session, and yeah, have a great like end keynote now. Thank you. Bye.